Alright, and welcome to Clayton's Pigeon Problem. Now, if you've never seen shooting clay pigeons, maybe you might be unfamiliar with this. You could Google it, but this is just kind of a form of sport shooting. Basically, more or less, someone will trigger a kind of like a catapult. It'll throw a clay disc, it almost looks like a clay frisbee, up into the air, and basically people practice shooting it with a shotgun. It's kind of a form of practicing for like quail hunting or dove hunting. Or you can even think to the classic Super Mario or the classic Mario game that has Duck Hunter on it. Alright, so with that context aside, we're just going to explore kind of a real world problem. Back to Clayton, he's just a simple man who loves to shoot clay things, so he's hired us to help him find the remains of each clay pigeon. He's modeled the shot of his rifle bullet as f of x equal to 1.43x plus 5.75. Now, I want you all to imagine this. And first, let me make this claim here. The majority of things that take place in the real world always are going to take place in what we're going to call quadrant 1. Notice that this is a simple linear function in the form y equals mx plus b. You probably can't really see that, but we know that our y-intercept is 5.75. So if I were to say like, hey, here is 5.75, we could more or less say this is where the barrel of the rifle is when he fires. And of course, he's firing at this rate of change. So no matter how fast the bullet is traveling, we would say that it's kind of going up at that height right there. Okay, so that's going to be the path that the bullet is going to travel. And of course, it's going to move through that path very quickly. Now, he's also modeled the mean flight path of the clay pigeon. One thing that we really haven't discussed is a lot of the whys or the hows of these things, but understand this, a quadratic function, anytime you throw something into the air, it will go up and it'll come down because of gravity. Because gravity is always exerting a downward force on us, everything that's thrown through the air or shot through the air or projected through the air undergoes what we'll call a quadratic motion. And so I was going to say, the flight path of this might take some sort of path like, let's just say like this. Now in this scenario number 1, Clayton could potentially hit this clay pigeon, either at the start or at the end. Let me draw a second scenario. Maybe in relationship to Clayton, the clay pigeon is fired behind him, so it's like this. Here, Clayton would only have one shot at shooting it. We really don't know what kind of scenario we're dealing with. So I'm going to erase the quadratic just for now, and we'll revisit this graph here at the end. Okay, so let's start this problem by setting these two functions equal. We can say, okay, negative 0.031 x squared plus 4x minus 3 is equal to 1.43x plus 5.75. Step 1, we always set our quadratic and linear function equal. Step 2, we want to solve for x. Now notice, since it's quadratic, we're going to have to move everything to one side and set this equal to 0. The opposite of positive 1.43x is negative 1.43x, and the opposite of positive 5.75 is negative 5.75. So I'm simply just going to move those things over, minus 1.43x and minus 5.75. Sorry, these decimals make it a little bit cramped, but that zeroes out, and our right side will equal 0. Now over here on the left, we're going to be given the function negative 0.031x squared. And let me just get my handy dandy calculator, because this won't work out as nice as we would like. Well, let's see. 4 minus 1.43 will give us plus 2.57x, and negative 3 minus 5.75 will give us negative 8.75. At least that one's easy. Now, I need a little bit of room to work here, so I'm going to clear off the picture just for the moment, and let's give ourselves some space. Okay, so I've written this out, and you'll notice that this is a very, very nasty looking quadratic function. However, fear not. Whenever we have a terrible looking quadratic function, we actually want to use the quadratic formula. So let's just start by labeling this as A, B, and C. And so what's our quadratic formula? Well, if you will recall, it's simply x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And what's the beauty of this thing? It will always work to solve literally every single quadratic. So we can write this as negative b plus or minus the square root of b squared minus 4ac all over 2a. And the only thing that'll be tedious about these are that these decimals are a little bit difficult. Okay, so let's see. Here we see b and b, so let's plug in our b, 2.57, 2.57, 2.57. Okay, here we see the letter A, and here we see the letter A, so we can plug in that negative 0.31, 031, kind of difficult to squeeze in there, 0.031. And lastly, we can plug in our C term, this negative 8.75. Okay, so what's this going to look like? Well, you'll just have to take a calculator and go kind of nice and easy. We know that negative times a positive, that's easy. That's just negative 2.57 plus or minus the square root of. Now, what is 2.57 squared? 2.57 squared is equal to 6.6 for simplicity's sake. Here we have a negative times a negative times a negative. Well, three negatives is still going to be negative. And let's see. And then we have 4 times 0.031, which is a very small number, 0.124, and we multiply that number times 8.75, and this is going to give us minus 1 point. When I multiply those three numbers together, I get negative 1.85. All over 2 times negative 0.031 will simply be negative 0.062. Okay, now from here we have a simpler equation, something a little bit easier to work with. Okay, let's go one step further. We can do negative 2.57 plus or minus the square root of, and I simply do 6.6 minus 1.085, which will leave me 5.515 all over negative 0.062. And now this kind of brings us up to here, and we want to take the square root of 5.515, which will give us a new number. So let me go ahead and write this out. X equals negative 2.57 plus or minus 2.35 all over negative 0.062. Now I'm going to stop right here, and I'm going to kind of clean things up just a little bit. So I would encourage you to pause the video, finish taking your notes up to this point, and then reconvene with me as well. Okay, so we have x equals negative 2.57 plus or minus 2.35 all over negative 0.062. Well, what's that really telling us? It's really telling us we have two solutions here. Negative 2.57 plus 2.35 all divided by negative 0.062. And we also have the solution x equals negative 2.57. Notice this plus or minus 2.35 all over negative 0.062. And so what are we really saying here? Well, you just want to combine what's on top first. In fact, I'll do both of these steps simultaneously. So let's see. Negative 2.57 plus 2.35 will of course give us negative 0.22 all over negative 0.062, comma, and over here we have x equals negative 2.57 minus 2.35, which will give us negative 4.92 all over negative 0.062. Now we simply have to divide both of these to find our x solution. So let's see. Okay, in this first x value, once I divide these two things, I'm going to get 3.3 3.55, comma, and over here I'm going to get 79.35. Okay, now these denote our x values, and let's go ahead and find our y values real quick. Okay, now notice here was our original system. F of x equals negative 0.031x squared plus 4x minus 3, and f of x is equal to 1.43x plus 5.75. Now notice we have our x values and we now need to plug them in. So what I would encourage you to do is always pick the easier one, or in my opinion, the linear function, and we'll simply write this twice. F of x is equal to 1.43x plus 5.75, and let's just write down here, f of x is equal to 1.43x plus 5.75. And let's go ahead and plug in our x values. Here in the top one, we can evaluate 3.55, 3.55, and in the bottom, of course, we can evaluate this 79.35, and of course, 79.35. Now remember, you'll need a calculator for this, but it should be pretty easy from here. And in fact, I'm just going to do this in one fell swoop. 3.55 equals, in this one you can do 1.43 parentheses, 3.55 close parentheses, plus 5.75. Very important you close that parentheses, and you'll get 10.83. Okay, now remember, this actually gives us the point 3.55 comma 10.83. Now down here we can do the same thing. In fact, let's just kind of skip to the end. We'll say, hey, 79.35 comma, and I can do 1.43 times 79.35 plus 5.75, and what do we get here? We get 119.22. Okay, and these are our two solutions. Now I'd encourage you to finish writing all this down, and let's bring it back to the photo, and let's really explain what all this simply means. Okay, here are our two solutions, and let's just kind of wrap this up. What is this really telling us? Well, what it's telling us is this. It's actually telling us that, hey, originally, remember, we said that Clayton's bullet is leaving the barrel at about a height of 5.75 feet. And what we're saying here is that it's then kind of following this trajectory. Now, I told you we would hold off on drawing the quadratic that the clay pigeon followed until the very end. But notice both of our x values are positive. So what would this imply? It would imply that our parabola is probably more or less going to look something like this, where it turns out Clayton will actually have two chances to shoot his clay pigeon. So if he is just like the fastest reflexes in the world, and I say that because 3.55 means that this clay pigeon is 3.55 feet away from him when he gets his first chance to shoot it. It seems pretty unrealistic that he would be able to shoot it that fast. Remember, bullets travel at the speed of about 1,200 to 2,200 feet per second. You know, so having the mental ability to hit something 3 feet away would be pretty insane. But what's the question asking? It says find the distance he'll have to walk to find the remains of his clay pigeon. So essentially we would say if he shot it at this point, well, he would have to walk about 3.55 feet. Okay, well, what if he shot it at this point? We're saying here that his bullet has traveled 79.35 feet, comma, and the clay pigeon would be at a height of 119.221 feet. And so more or less, if he were to hit the clay pigeon here, well, he would have to walk this distance. All right, I hope this helps. So remember, in this case, there are two answers. If he shot it here in the very beginning, he would have to walk 3.55 feet. And if he shot it way over here on the right, which is more likely, he would have to walk 79.35 feet. I hope this helps, and I'll catch you guys in our next video.